Hello everyone, welcome to In 5 Minutes. In this particular video clip, we will discuss one problem on superposition theorem. This was a question asked in December 2014 paper. The question is find the value of current flowing through 5 ohm resistance. As you can see, there is only one 5 ohm resistance connected between points A and B. So we will find out what is the current through this particular branch. They have not mentioned the direction of the current, and hence we can assume any direction that we want. So let us define current through 5 ohm resistance that is flowing in downward direction. I'm going to call it current I. Now the question further says we have to use superposition theorem. So this is something very important. We have to solve this only using superposition theorem by not any other approach. There are three different sources, so we'll have to solve the question in three different steps. We will first consider, let's say, 10 volts active in the circuit, replace the two current sources, and in step 3 we will consider each of the two current sources active. So let's start with step 1. So in step number 1, 10 volts is active. If this is the 10 volts that I'm going to keep active, I'll have to replace the current sources. Current sources are always open circuited, so I'll remove this 5 ampere current source. The moment I remove it, open circuit, you can see this 3 ohm branch is not connected anywhere else, and hence it will not carry any current. So this will simply become a branch that we don't have to consider in the calculation of I. Similarly, this 2 amperes current source will also be removed from the circuit because current source should be replaced with open circuit. So this is the resulting circuit that we have got, and in this circuit I have to calculate this current I that is flowing in downward direction. Now one can use mesh analysis because there are two different meshes, as we can see. But more than mesh analysis, what I feel is the circuit can be easily simplified. As you can make out, 6 ohm, 3 ohm and 4 ohm resistors are in series, and that series resultant resistance will come in parallel with 10 ohm resistance. So if I replace all these resistors using series parallel combination, we will be left out with one single loop. So my resulting circuit, this 3 ohm resistance is of no use anymore, so I will directly start with a 5 ohm resistance. 6 ohm resistance will remain, and all these resistors will be replaced by single resistance. This is 2 ohm resistance, this is 10 volts battery, this is 6 ohms, this is my 5 ohm resistance. I want to find the current through 5 ohm resistance. I'll call it I1 because right now I've considered only one source active. So you can see I can easily find I1 using simple Ohm's law. Because all the 4 resistors are in series, I can further combine these resistance, replace them using single resistance. So let's do that. Before that, let's calculate the value of this particular resistance. As we just discussed, it's going to be 6, 3 and 4 in series, and that will be in parallel with 10. So this will be equal to 13 in parallel with 10, and that will be further equal to 5.652 ohms. So this is my resistance, 5.652 ohms. And now let us draw the further one equivalent circuit in which there will be only one resistance. So I will just show one resistance. 10 volts battery will remain as it is and nothing else apart from that. This is 10 volts battery as it is, and the single resistance will be sum of all these resistors in series. The resistors are 6 plus 5, that's 11, plus 2, that's 13, plus 5.652, so 13.5 will be 18. So this resistance becomes 18.652. And originally my current I1 will keep flowing in this particular direction. So now you can see that I can find out I1 using simple Ohm's law. My I1 is going to be equal to, it is single voltage source 10 divided by resistance 18.652. But if you observe carefully, if the current flows through this 10 volts battery, it will be flowing likewise in clockwise direction because the current always comes out of the positive terminal, whereas I1 is flowing in the opposite direction. So the value of I1 will have negative sign in it. So my I1 finally becomes minus 10 upon 18.652, which will be equal to 0.536. So I1 becomes 0.536, but obviously with minus sign. So this is my equal to minus 0.536. So that's the value of I1 that we have got. So now let us go to the next step, step number 2, where we will keep one of the two current sources active and find out the value of current I, calling it I2.